Hello and welcome to lecture series on elements of machine design. In previous two lectures, we have seen the introduction to the syllabus of elements of machine design. What is meant by machine design? Classification of machine design. Design principles of designing any component. How the factors are considered while designing any component. Now in this lecture we will see what is the basic procedure of machine design. Myself, Mr. S.S. Mari, HOD Mechanical Engineering Department, Sharathy Institute of Technology, Polytechnic, Hyderabad. So just have a look the basic procedure in machine design, that is the general procedure in machine design. The first step in any process of machine design is the market survey and recognition of need. There is no firm rule how we can design the component. There is no firm procedure how we can follow that. But there are some factors or there are some steps that we need to follow while designing any machine component. So these are the in general steps that any design engineer can follow for designing any particular component. The first and foremost need, that is the first step of basic procedure of machine design, is market survey and recognition of need. It is very important to understand what is the need behind the designing any component. That means, first of all, we have to make a complete statement of the problem. What is the problem? Why we are designing that component? What is the need of designing that component? What is the aim or purpose for which the machine is to be designed? Means we have to first of all understand what is the purpose of designing any machine component. That for that purpose we have to carry out the market survey. Unless and until we do not carry the market survey, we do not come up to the point that what is the problem that is faced by the customer. When we understand what is the problem faced by the customer, then we recognize the need. What is the need of the customer? And when we get what is the need of the customer, then we will decide what is the aim for which the machine is to be designed. So this is the fundamental step before starting your design procedure or design of any component. As a design engineer, you should carry a market survey, and from that market survey you come to know what is the need of an hour. And when you decide the need, then you formulate the purpose for designing that basic component, and then you start your design procedure. So this is the first step in designing a machine component, that is the market survey and recognition of need. Now next is the define specifications of the product. Now specifications of the product means any information which gives an idea about the overall performance of the product, overall information of the product. That is known as the specifications of the product. In consumer products, external appearance, noiseless performance, and simplicity in operational control are important requirements. Now to understand what is meant by the product specification, what is meant by the deciding the specification, just look at the simple example. For example, while designing a scooter, take an example of scooter, the list of the specifications will be as follows. Specifications means the parameters which actually reflect or actually affect the performance of that scooter. Means in general we can say specifications are the list of the items, list of the parameters that actually affect the efficiency or working performance of that machine component, that is the specifications. So if you want to design a scooter or any element of a scooter, first the product specifications of that scooter are what will be the fuel consumption, what will be the maximum speed of that scooter, what is the carrying capacity of that scooter, how many load it can carry, then overall dimensions, that is the geometrical parameters of that scooter, what will be the width of that scooter, what will be the length, what will be the height, what will be the gross weight of that scooter, overall weight of the scooter, and foremost point, what will be the cost of that scooter. So these are some important parameters that need to be considered while designing of any component. That is means we have to first of all decide the product specifications. By considering the specifications, you are designing that component. When you decide the specifications, that means you have an idea what you have to do, and after getting that idea or clear view, you go for the design. So first step is the market survey, that is the recognition of the need. Second step is the defining the product specifications or deciding the product specifications. Apart from this, if you take the example of the scooter, then in consumer products, external appearance is one of the parameter, noiseless performance and simplicity in operation of controls are important requirements, and depending upon the type of the product, various requirements are given weightage and a priority list of specification is prepared. So this is the second step, that is the basic design procedure to decide the product specifications. Now after recognizing the need, after understanding the purpose of designing a machine element, after understanding the aim of that component, after deciding the specifications of that component, the next most important parts come into mind is the selection of mechanism. How that machine will operate. There are different mechanisms available for a certain component, but when you are going to design a certain component or any machine or any product, then as a design engineer you should decide what kind of a mechanism it should be involved or how it works. That means understanding the working principle of that component or that machine. Now select the possible mechanism or group of mechanisms which will give the desired motion. A machine will operate to different mechanisms. If we take the example of a simple blanking or piercing press as shown in a diagram, a mechanism involving the crank and connecting rod. Now in this case, a mechanism involving the crank and connecting rod converting the rotary motion of the electric motor into the reciprocating motion of the punch. This electric motor will convert the rotary motion of this electric motor into the reciprocating motion of this punch. So while designing a piercing machine, say piercing press or blanking press, so this is the machine component that we have to design. Then we have to select this mechanism. Means transfer of motions. How elements will have motion with respect to each other. How the elements will move with respect to each other. That is the selection of the mechanism. And while designing a component as a design engineer, you should select a mechanism in such a way that it will operate in a simple way. Means the main focus should be on selecting a simple mechanisms in a machine component. That will be the easier, or that will add to the efficient operation of that machine component, or it will also help to reduce the cost of the machine component. It will also reduce the design criteria, or what we can say design difficulties while designing a machine, while determining the forces. So this is the next important parameter, that is the selection of a proper mechanism. Another example is a mechanism involving nut and screw, which is a simple and cheap configuration but having poor efficiency. Now this is also another parameter. If you select the simple mechanism, you need to concentrate on the efficiency of that mechanism, how this mechanism will operate. If you select a simple mechanism, that is another part, or that is the another side of the coin. One part says you have to select the simple mechanism, but also you have to look for the efficiency of the machine element. So that is the selection of a proper mechanism. Take another example of mechanism. A mechanism consisting of a hydraulic cylinder. Now this is the hydraulic cylinder, mechanism consisting of a hydraulic cylinder, piston and valves, which are costly configuration but highly efficient. Though this is a complicated one mechanism, but it will give a highly efficient results. The alternative mechanisms are compared with each other and also with the mechanism of the products that are available in the market. Now, if you are designing a certain product, then first of all you have to compare the what are the mechanisms actually available in the market. If you're designing the same product but with different mechanism, then you have to study these different mechanisms of that simple product or that component. An approximate estimation of the cost of each alternative configuration is made and compared with the cost of existing products. This will reveal the competitiveness of your product. That is the most important. Competitiveness of your product. Means if you are designing or if you are manufacturing a same product which is actually available in the market but with a different mechanism, but you need to consider the efficiency of that mechanism as well as the cost of that mechanism. If your product will become too costly, then it will not place in a market. That's why you need to concentrate on the efficiency as well as the cost of that product. That is the most important role. That is the selection of a proper mechanism, so that the machine component will operate in a simple way, as well as the efficiency of the product will become much more, as well as it will reduce the cost. So that is the selection of a proper mechanism. Now next part is the selection of the layout of a configuration. How should be the configuration of your machine product or your machine component? That is the configuration. In machine configuration, that is the design procedure, is to prepare a block diagram showing the general layout of the selected configuration. For example, the layout of a car consists of the following components. One example is taken. How we can select a particular layout when you are designing actually component. How you can select a particular layout. The major system of the automobiles are the engine, including lubrication and cooling, the fuel system, including evaporative emission, and the ignition system, including the electrical system, including starting and charging, the exhaust system, including emission control, the drive chain, including the transmission, the suspension and steering system, the brake system, and the frame and the body. So this is the in general configuration of your automobile car. In this step, the designer specifies the joining methods such as riveting, bolting, or welding to connect the individual components. Rough sketches of shapes of the individual parts are to be prepared. That is the selection of the layout of a configuration. That is to prepare a layout of a configuration. How you will going to join a simple components with each other when you are actually assembling that product. That is the layout of configuration. Now next part comes into part is the design of individual components. And when we say a design of individual components, in this step actually there are two more steps, sub-steps. That is the analysis of the forces and material selection. When we can say we have to design of an individual component. Now first we have decided the need, we have carried out the market survey, we have decided the need. After deciding the need, we have given the product specifications. After deciding the product specifications, we have selected the proper mechanism. After selection of the proper mechanism, we have prepared a layout, a particular layout of configuration. After preparing layout of configuration, the next step is to design a machine component. Actually, now we have arrived at the main step, that is the actual design of the machine component. Now, in designing the machine component, the sub point, that is the sub criteria, is the determining the forces acting on the component. It is the most important element. You need to analyze you need to find the forces which is acting on each member of the machine and the energy transmitted by each member. That is the design determining the forces acting on the component. It may face tensile, it may face compressive force, it may face shear force, it may face bending force. So you need to calculate the different types of the forces acting on the component. Then next part is the select proper material for the component depending upon the functional requirement as strength, rigidity, hardness, and wear resistance. That is the most important part while designing a machine component. That is, you need to select a proper element, you need to select a proper material which is best suited for each member of the machine. Now, if you are going to design a particular machine, as in first lecture we have defined what is meant by the machine. It is the combination of different mechanisms or different elements. Then if you are designing an individual element, then you have to select, you have to decide a particular element, you have to decide a particular material or a particular element. That is most important. That is the selection of the material depending upon the requirement, depending upon the functional requirement of that element. Next part is the determine the likely mode of failure, means how that component will fail. That is the determining the stresses which is acting in the element, which is inducing in the element. That is the determining the failure criteria of that component. Select the criteria of failure such as yield strength, whether it is a ductile material or brittle material, ultimate tensile strength, endurance limit or permissible deflection. Now yield strength or ultimate tensile strength, it will depend upon the which kind of the failure it will occur, whether it is a ductile material or brittle material, or that element is subjected to reverse type of the loads, fluctuating loads, impact loads. Now depending upon the nature of the load which is acting on the component, the material will undergo different types of the failures. Means first and foremost criteria while designing a machine component is to select the criteria of failure, and by considering that criteria of failure, you are actually using the equations, you are actually using the design equations for designing that particular member. That is the actual design criteria for designing a component. Means these are the three sub steps which is included in the actual design of an individual component. That is the design, determine the forces acting on the component, select the proper material depending on the functional requirement, and determine the likely mode of failure of the component due to the induction of the stresses. Next part is the determine the geometric dimensions of the component using a suitable factor of safety. That is most important. By considering the mode of failure, by considering hazards of that failure of component, by considering effect of that failure of component, we have to decide the factor of safety. And by considering the factor of safety, we have to modify the dimensions from assembly and manufacturing considerations. By considering the manufacturing processes, by considering the assembly processes, you have to modify the dimensions of the existing component by giving some factor of safety. When we are giving a factor of safety, means we are actually going towards the safe criteria. That is determine the dimensions of the component by using a factor of safety. So these are the four sub steps in the design of an individual component. Now in the design of individual component, again I want to add one more step, that is the determination of the stresses. When actually you are likely to determine the mode of failure, means actually you are determining the stresses which is acting in the element. By considering that stresses, you are actually deciding the mode of failure. It should be keep in mind that each member should not deflect or deform than the permissible limit. Means you have to take into account the permissible limit of that component, permissible stress of that component. By considering that permissible stress, the nature of stress which is induced in the component, you have to decide the criteria for failure. That means you have to decide the design criteria depending upon the induction of the stress into the component. So once again we can conclude the step number 5 consists of 4 main steps. That is the first, designing the or determining the forces acting on the element. Second, selection of the proper material depending upon the functional requirement of that element. Third step, determining the mode of failure. That means you have to determine which type of stresses are induced in the component and what is the nature of that stress due to which that component will get fail. And by considering that stress, that failure stress, we have to design the component. And fourth one is the determining the geometrical dimensions of the component using a suitable factor of safety, so that we can go to the safe side by considering assembly and manufacturing considerations. So this is the step number 5. It is the design of individual component. Now after actually carrying out, now in first lecture we have actually seen what is meant by the actual design. Design means nothing, design is nothing but determining the dimensions of the component. And after determining the dimensions of the component, you have to go for the preparation of drawings. Means you have to prepare a detailed drawing of that particular process. The last stage in design process is to prepare drawing of the assembly and the individual components, because in step number 5 we actually determine the dimensions of the component. And after determining the dimensions of the component, when we get the different dimensions of the component, you have to prepare the drawings, and on these drawings the material of the component, its dimensions, its tolerances, surface finish grades and machining symbols are specified. It is known as the production drawing. Means by looking at the drawing, a design engineer can understand what is the actual dimensions of the component, how that components will get manufactured, what are the different tolerances provided on the component, what is the requirement of the surface finish grades, and which kind of the machining process has to be carried out on that component. That is the preparation of the drawing. This is one of the most important step, that is the preparation of the drawing by considering the dimensions of the component. After preparing the drawing, the designer prepares two separate lists of components. That is the standard components to be purchased directly from the market and special components to be machined in the factory. In consideration of the design, we have seen one parameter, that is the cost of standard parts, use of standard parts. Now when you are preparing the drawings, that means if there is availability of the standard parts in the market, you can directly purchase that standard parts from the market, and if you are required some special parts for that assembling purpose, then the special components are machined in the industry itself. In many cases, a prototype model is prepared for the product and thoroughly tested before finalizing the assembly of drawings. That is most important. You have to prepare two different lists, that is the standard components and the purchased one. That is actually which is required at the time of the productions. Now, it is seen that the process of machine design involves systematic approach from known specifications to unknown solutions. Quite often problems arise on the shop floor during the production stage, and design may require modifications. Now, if a design engineer had prepared the drawings, he had made the assembly drawings, but due to some manufacturing defects, due to some limitations, sometimes you need to change the drawings. In such circumstances, the designer has to consult the manufacturing engineer and find out the suitable modifications. If now in this step we have already decided which kind of the manufacturing process is suitable for that. Now after preparing the detailed drawings, means after preparation of the detailed drawings, the next step comes to the assembly of the components. Means after preparing the preparation of the drawings, after determining the component dimensions, after manufacturing the components, the last part comes, that is the assembling of the component. That is the component as per the drawing is manufactured in the workshop and it is assembled. That is the design procedure. So once again we will go through the steps of the design procedure one by one, what we have seen. First, we have seen the recognition of the need. Then we have seen you have decided the product specifications. Then we have considered the layout of configuration. Then we have determined the different design of the components by analyzing the forces acting on the component. Then we go for the preparation of the drawing, that is the preparation of the detailed drawing, and last one is the assembling of the components. That is first market survey and recognition of need, defining the specifications of the product, what are the different requirements of the product, study of alternative mechanism, that is the selection of the proper and simple mechanism, as well as that mechanism should be efficient one, that is the selection of the mechanism. Then preparation of the general layout of configuration, how you are going to assemble or how you are going to join the different small elements of the machining component, that is the preparation of the configuration, and select joining methods between individual components of the product. Then design of the individual component. In design of individual component, again there are three subtypes, basic steps, that is the analysis of the forces, that is the forces acting on the component, selection of the proper material for that particular component, determining the criteria of failure for that particular component, and modifications required for that particular component. Then design individual components, that is the basic steps. And last one is the prepare assembly and detailed drawing and modify drawings after testing prototype model. That is the basic procedure of machine design, which is followed in general while designing any machine component. I hope you will understood the basic procedure of machine design for a particular element.